Good morning. That was pretty pathetic, wasn't it? Should we do it again? I don't know. I always feel it's a bit forced, but good morning. There we go. Great, great. Mainframe, modernization, and migration. Taking the enterprise on a multi-year journey to boldly go where no one has gone before. Hence the graphic. Hi, my name's Paul Holland. I'm the CTO of Astadia, which is a subsidiary of a company called Amdocs. Astadia specializes in helping people modernize and migrate applications off their mainframes, do a lot of work in the financial services space. And Amdocs has a great history of successfully delivering large transformation projects. Originally did a lot of work in the telco space and now progressively doing work in financial services with banks and big insurance companies. So what I want to do just over the next 13 minutes is talk about why organizations are focusing on modernizing mainframe workloads, and then what we're seeing in the financial services sector in terms of the kind of approaches people are taking and the sort of goals that they're laying out for themselves in doing that. Now, I'm a techie, and I'm probably going to get a little bit techie, but I'll try and keep it as high level as possible. So why are people even considering moving away from mainframes? Mainframes have been a phenomenally valuable workhorse for financial services organizations, for banks and insurance companies and capital market firms for years. They do a great job. When it comes to high volume transaction processing and vertical scalability, they really do deliver with consistency and resilience. But there are pressures around mainframe usage today, one of which is business agility. Business is changing rapidly, and systems need to keep up with those rapid changes. But also skills, and we'll talk a little bit more about this, but the resources and the institutional knowledge around mainframe workloads. And lastly, and of course not least, is cost. Cost is always an issue, and cost is an issue when you look at mainframe compute. If you consider the applications that you're running on your mainframe systems, many of these applications are 20, maybe even 30, or even 40 or more years old in their origins. They've been on those platforms for literally decades. And as time's gone by, they've been changed progressively by a variety of different development teams, different outsourcing companies. And that means these applications over the years, over the decades, have become very brittle. They contain a lot of what's known as technical debt. A lot of coding that was done the way it was done 20 years ago, 30 years ago, because that's the way you did it 30 years ago. But you don't necessarily do it that way today. And that means that these applications over time have become very resistant to change. They're difficult to change, they're large, and they also have code areas that nobody really knows much about, and therefore they don't want to get changed. They're sort of no-go zones. People don't want to go there. And this is compounded by the issue that we're all facing today around technical skills for developing and operating mainframe applications. The reality is that the technologies that are used for most of these applications on the mainframe are old technologies. One of the ones you've probably heard of is a programming language called COBOL, which was first developed back in the late 50s and is still widely in use on mainframes today, but not anywhere else. So there's a gap in the skills available in the industry now for working with these old mainframe applications. But the other issue on the skills side is, I'm sure if you look around your organizations and you look at the people responsible for maintaining your mainframe applications, they tend to look a little bit like me. One of the people in our organization calls us the no hair, gray hair, or hair products group. And the reality is we're all leaving the business. We're all heading out for our retirements or beyond. And that means a lot of institutional knowledge is leaving the business as well. And then lastly, costs. The mainframe cost model is a completely different cost model to what we see in any other type of compute platform these days. It's heavily centric based on maximizing your usage. There's no sort of scalability of your costs. You pay for the very most that you're ever going to use, and the numbers are high. So costs, skills, and flexibility and agility are big drivers to do something about mainframes. So what are people doing? Well, the first thing they're doing, and we see this a lot in financial services, is they're starting to look and implementing a hybrid compute model. So looking at how to lay out processes, business processes, over not just the mainframe, but distributed, and now progressively the cloud, including public cloud. So hybrid compute is really the infrastructure model that we're seeing prevalent in financial services. But that means that you need to start to think about where are you going to do the different computing. Now, it's certainly true if you look at banking, insurance, a lot of the channels have been moved out to distributed, moved out even to cloud. But now we're seeing progressively the need to take more of the core processing and move that and distribute that out across these variety of hybrid platforms as well. In order to try and address the flexibility requirement, the idea of putting APIs around everything is very common. We're seeing, even at the core, the need to open that up and create interfaces so that things can be integrated together across this hybrid compute strategy is increasingly important. So API everything is something that we see a lot in banks. And then the idea of actually modernizing the technology stack that makes up these applications at the core. This is now a big job, but it's a job of breaking down those monolithic workloads that you see in these core applications. And this is difficult, particularly if you think in the banking model, the core platforms, your core banking platforms are obviously very mission critical. They're very complicated. In some cases, they're based on third-party frameworks. So you may not have the opportunity to actually modernize that fundamental core. Or if you do, you want to do it very, very carefully. So a lot of organizations are taking an approach of really looking at the periphery of the applications and workloads around that core and starting to modernize those away from the mainframe and adopt this pattern of what's called strangling the core or strangulation pattern, so that you're isolating the bare minimum of what you need to keep on the mainframe as a tactic. But this is hard to do. The reality is that a lot of the operations in your business have been built up around these siloed application workloads on the mainframe. So the business is aligned to the applications. And if you start changing the applications, then you need to change the business as well. So there's an impact around that. Technical debt makes it difficult to make changes, but at the same time, it gives you an opportunity to drive out technical debt as you address these issues. And then there's where you start. And starting these jobs is actually always the hardest thing. There's enormous inertia getting these things off the ground. So the reality of understanding your current state is absolutely critical to the success of a mainframe modernization program. And what we're seeing now is understanding the current state was always a common requirement for any modernization roadmap. But now and that was largely focused on what is it I've got? What is it? What is it in terms of number of programs? What is it in terms of technology? What is it in terms of the database? But what we're seeing now, particularly in banks and insurance, is I also want to know what it does. I know I've got all this code, but I actually don't have very good documentation of what it does as a business function level. And I know, because it's 30 years old and it's running the business today, there's probably functionality in there that's pretty important, but I haven't got a good handle on it. As well as understanding the current state, it's incredibly important to have a clear understanding of where you're trying to get to. So the target state design is critical. And we're seeing that now, if you think in banking terms, a lot of emphasis now on domain architectures, product-centric architectures, building out that architecture, that picture of what the bank looks like from a systems point of view for the next 10, 15, 20 years. And there's a lot of standardization efforts going on around that in banking in Europe. BIAN is a common banking architecture that we see companies adopting. But most companies are maybe going more out on their own in that sense, but basing it on some of the good thinking that has gone into some of these common architectures. And then critically, in order to exploit those architectures and deliver the agility and flexibility that the company needs, the move to microservice, more modular computing is critical. So you have to start this process by building out your disposition analysis. What are the different patterns you're going to adopt to move to these new architectures? Move the technology stack, get yourself into a Java stack or a .NET stack as part of this process. Eliminate the technical debt. Refactoring is a particular modernization pattern that can really help with this in terms of moving away from the current technology stack. Refactoring gives you a way of an automated code conversion that takes you wholesale, at scale, from the legacy technologies on the mainframe to a modern technology stack, such as Java. Now, the other thing that refactoring can do as you start to transition to that full journey of a microservices end state is it can get you into a common, steady state, technical stack, before you then move into the microservices. So the issue on your mainframe is a lot of your business functionality will not only be in the main programming language, let's say COBOL, but it might be in things like assembler, it might be in certain scripting languages that are part of your batch processing environment. So it's all embedded in a mishmash of technologies. The idea of refactoring everything into a common state, even if you don't deploy that into production, but you get everything to a Java state or you get everything to a .NET state, allows you to then use things like GenAI, which we're doing a lot with now, and GenAI agents, to then mine the business functionality from that common state so that it can be rendered out into new processes, into microservices that can fit into your target environment. And of course, we've got to actually fix the plane while we're flying it, right? So all the time, these programs need to take into account the ongoing requirements of the business and keep the lights on a day-to-day basis. So with proper forethought, proper planning, good analysis, leveraging automation to get to common states, technical states, and then leveraging GenAI and GenAI agents now to actually mine the business functionality in these applications, it gives you a pathway to get to a completely re-architected end state. This gets you to greater agility, breaks down the silos and the operations that goes with those silos, so the business aspect improves as well, and gives you the opportunity to move those workloads off the mainframe and optimize your costs. Astadia delivers across the entire program range, from initiation, disposition analysis, all the way through the automation and technical steps that facilitate this kind of modernization program. So, thank you.